Well, right now, road crews are continuing to plow the streets, including I-280, and put down salt to melt away the ice. But how does it work, and could your kitchen salt be just as effective? Jeff Smith is with the Imagination Station's chief scientist, Carl Nelson, to put it to the test.
So another one of those things you hear this time of the year. We've been talking about the Ohio Department of Transportation, the city crews. They're all out there. They're looking for rock salt to put down in the roadways to make travel safer. And you said, Carl, there is real science behind how this stuff helps us stay safe on the road.
Absolutely. Let's go right to what you're thinking.
Okay.
I have some table salt, some sodium chloride. Go ahead and sprinkle a little bit on this side of this slab of ice.
Just right here?
Yeah, this is like our roadway. This is some ice on the road. Now, when you talk about...
How much?
I think that's pretty good. That's
I feel like we're making a recipe here.
Yeah. So when you talk about salt, there's actually a couple of different kinds of salts that they put on the roads. Now, you mentioned rock salt or sodium chloride. Whenever you have a surface that's frozen with ice, there's always a thin layer on the top that is made up of water.
And this is just a simple sheet of ice, right?
I just froze this in our freezer, right?
Yeah.
You add the salt on top, that thin layer of water allows those ions, the sodium and the chloride, to dissolve into the water. And basically the simplest answer is what happens is they interfere with the ability of the water molecules to form a regular ice crystal, a lattice.
Yeah.
They just interfere. And so this is called freezing point depression. And with sodium chloride, that works well maybe to like 15 degrees above 0 Fahrenheit.
Yeah.
Now, today, this week, this month, we're well below that, right? So you need a different tactic or a different compound. And that could be calcium chloride.
Okay.
Okay, so go ahead and sprinkle that on the
Down
other
the
side.
middle?
I'll
I'll
do it on
put
the other
that
side,
in
yeah.
right over here on this side.
So you'll often hear, if you buy rock salt, it'll have sodium chloride. Ice melt will often have calcium chloride in it.
Yeah.
And what happens here is the calcium chloride can actually work down to 25 below 0 Fahrenheit. And a more subtle way to think about this, other than just hand waving and say it interferes with the lattice, is that when those ions get ripped apart, sodium chloride, calcium chloride, that takes energy. You gotta rip those things apart. Okay, so you gotta put energy in, but once they're loose, floating around in that solution, the water molecules start to surround them. It's called hydration. And that's a lower energy, it's a happy spot for the ions. And that gives off heat. If we add those two numbers together, the energy to rip it apart plus the energy to let them relax, if it's a positive, it'll give off heat. And if you look at this up close, you can see like these little calcium chloride spheres.
It's down inside the ice.
Just down inside the ice.
Yeah.
In fact, that calcium chloride gives off a tremendous amount of heat. Here, let me give you this. That's calcium chloride inside there. This is a little bag filled with water. I'm gonna put that in, seal up the bag, and we'll do a little experiment. This is actually how you could make a hand warmer at home with your ice melt.
Okay.
So I'm gonna, just because it can get messy,
Yeah.
I'm gonna put it inside a secondary bag. We're gonna seal that up. And now I just want you to smash it really hard with your fist so we can break that inner water bag and the two chemicals can mix.
Okay.
Good smash. Perfect. Now pick it up and mix it around. Describe how that feels.
It's getting warmer. It's getting warmer. Yeah, it's borderline. I mean, if you're making hot tea, it's about that temperature right now.
It's going to get to the point where it could be uncomfortable to hold. That release of heat energy is what makes the calcium chloride so much more effective.
Yeah.
It's because you can even see our sodium chloride not doing a whole lot. I mean, a little bit. Over here, we're actually melting through and releasing some liquid water.
Wow. And this is to the point, this is like pretty hot.
Yeah. Now, calcium chloride's more expensive, so when the road crews go out, if they can afford it, they'll do the sodium chloride because it's cheaper. Right? But if the temperatures get too low, this is ineffective. We might step up to calcium chloride, even magnesium chloride, which is even more expensive than this. So there's a trade-off in terms of cost and effectiveness and at what temperature it works.